powerful tool in discrete math used to manipulate sequences called the generating function. The idea is this. Instead of some infinite sequence, we look at a single function which encodes the sequence, but not a function which gives the nth term as an output. Instead, a function whose power series, like from calculus, displays the terms of the sequence. So for example, we would look at the power series for 2 plus 3x plus 5x squared plus 8x cubed and so forth. This would display the sequence 2, 3, 5, 8, and so forth as coefficients. An infinite power series is simply an infinite sum of terms of the form Cn x to the n, where Cn is just some constant. So we might write a power series like this. The sum up to infinity from k equals 0 of ck x to the k, or expanded, it would look something like this. C naught plus C1x plus C2x squared plus C3x cubed, and so forth. When viewed in the context of generating functions, we call such a power series a generating series. The generating series generates the sequence C0, C1, C2, C3, and so forth. It encodes that sequence. The power series, the generating series encodes the generated sequence. In other words, the sequence generated by a generating series is simply the sequence of coefficients of the infinite polynomial together. What sequence is represented by the generating series 3 plus 8x squared plus x cubed plus x to the 5th over 7 plus 100x to the 6th, and so on? We just read off the coefficients of each x to the n term. So in this case, we know that a0 equals 3, since the coefficient of x to the 0 is 3. X to the 0, by the way, is 1, so this is just the constant term. What's a1? Well, it is not 8, since 8 is the coefficient of x squared. So 8 is the term for a2 of the sequence. To find a1, we need to look for the coefficient of x, which in this case is 0. So a1 equals 0. Continuing, we have, again, a2 equals 8, a3 would be 1, a4 would be 0, a5 would be 1/7. So we have the sequence, in this case, 3, 0, 8, 1, 1/7, 100, and so forth. Note that when discussing generating functions, we always start our sequence with a0. Now you might very naturally ask, why would we do such a thing? One reason is that encoding a sequence with a power series helps us keep track of which term is which in the sequence. For example, if we write the sequence 1, 3, 4, 6, 9, and so forth, and then 24, and then 41, and so forth, it's impossible to determine which term 24 is, even if we agree that the first term was supposed to be a0. However, if we wrote the generating series instead, we would have 1 plus 3x plus 4x squared plus 6x cubed plus 9x to the 4th, and then plus plus 24x to the 17th plus 41x to the 18th and so forth. Now it's clear that 24 is the 17th term of the sequence, meaning that this is a 17. Of course, to get this benefit, we could have just displayed our sequence in any number of ways. For example, we could have written, in this case, 1, 0, 3, 1, 4, 2, 6, 3, 9, 4, 24, 17, 41, 18. We could have put little subscripts there, I guess, but we don't do this. The reason is that the generating series looks like an ordinary power series, although we are interpreting it differently. So we could do things with it that we ordinarily do with power series, such as write down what it converges to. For example, from calculus, we know that the power series 1 plus, and I'm actually going to erase this all real quick. 1 plus x squared over 2 plus x cubed over 6 plus x to the fourth over 24, and so forth. In general, plus x to the n over n factorial. This converges to the function e to the x. So we can use e to the x as a way of talking about the sequence of coefficients of the power series for e to the x. When we write down a nice compact function which has an infinite power series that we view as a generating series, then we call that function a generating function. In this example, we would say 1, 1, 1/2, 1/6, 1/24, all the way up to 1 over n factorial has the generating function e to the x. So this generates the sequence 1, 1, 1/2, 1/6, 1 over 24, 1 over n factorial, and so forth. Anyways, thanks everyone, and I'll see you in the next video.